All right, let us look at this question number 3 on this equation of motion. So the question reads, a motor car traveling at 54 kilometers per hour is brought to rest with uniform retardation in 5 seconds. Find its retardation and the distance traveled in this time. Okay, so one thing about motion that is brought to rest, it means the final velocity is 0. So that means the car has retarded. Either the brake is applied or any other factor. Now, given to us solution. Given to us here, we are giving the initial velocity, which is u equal to, which is what? 54 kilometers per hour. Then the next one that is given to us is the time. Time is equal to 5 seconds. So there is no consistency here. We cannot work with seconds. Since we are working with kilometer here, we are giving in kilometer per hour. So it means this seconds here has to be changed to what? Hour. And we know that what? 60 seconds make 1 minute, and 60 minutes make 1 hour. So in that case, we are going to be dividing this 5 by what? 60 times 60. So that your time will give us 5 over, that is for 3,600 hours. That is the time. So now, for objects that comes to rest, it means final velocity is equal to 0. Now let us look at which of the equations now we are going to use that contains acceleration, because acceleration now is now the negative side, which is the retardation. Look at the equation we are going to use, v equal to u plus at. So we are looking for a, because a is unknown. That is the deceleration we want to look at. Since the final velocity is 0, so this side becomes 0, then equal to, what is our initial velocity, which is 54, then plus a times, what is your time? 5 over 3,600. So of course, we can move this one to this side, because negative 54 equal to 5a over 3,600. Now let us cross multiply. We can have 5a equal to negative 54 times 3,600. Now let us calculate. So your a is going to give us negative 54 times 3,600 over 5. Let us get our calculator and finish it. Minus 38,800 at what? Minus 38,880 kilometer per hour squared. It will be per hour squared. So this one is the deceleration. That is the retardation. Then the next one we want to look at again, and we are told the distance traveled in this time. So which of the formula do you think we are going to use that has to do with distance? We also have S equal to UT plus half AT squared. We have this distance. Let us apply that. S becomes equal to, what is your initial velocity is 54 times, what is your time? 5 over 3,600. Now acceleration now becomes negative, because we are having negative here. That becomes minus 1 over 2. Then we have 38,880. Then multiplying 5 over 3,600, then all squared. Get your calculator. Let's go. Just compute everything. This one times this one, 54 times 5, then divide by 3,600. So you bring it down here. Then square this one, square this, then multiply this one, okay? This one here, square 5. Then 5 square will give us what? 25. Then multiply 38,880. Then you write it as your numerator. Then this one here, multiply this one, the square of this one. You square it, then you multiply this. And at the end of the day, what we are going to do now, let's first of all work with this one. This one times this one, then divided by 3,600. So let's work it out. At the end of the day, we can reduce it. We have 3 over 40, then minus. Let's go to the other one. So after the computation, we have 3 over 80 on this other side. The whole of this thing, evaluating everything, gives us 3 over 80. Now we can find the LCM. So this LCM is 80. The LCM here, 80. Then this gives us 2 times 3, that's 6 minus 3. So S becomes 3 over 80. So kilometers. We leave the answer like this. So this is our answer. If you find this class interesting, please help us to share this post and do well to like and comment. Bye.